like we had before, in addition to expanding and condensing with properties of logs, we can go ahead and we can solve equations. We're just going to be looking at the common log and the natural log now. So for this first problem, I want to start off by condensing the left-hand side. So I'm going to pull that 2 up into an exponent to start off. So this is log of 25 plus log of x squared is equal to 2. All right. And then I'm going to condense further because I have the addition here. That means I can condense this down into a product on the inside. So this is the log of 25x squared, and that's going to be equal to 2. Okay. Now, because I don't have log equals log, I can't use the property of equality, so I do need to convert this to exponential form. So I do need to go back and identify, well, what's the base in a common log? And this is the base 10. So now I can write this in exponential form. So I'm going to have our base 10 to our exponent 2 is equal to the inside expression 25x squared. And that 10 squared, well, that's really a 100. So we have 100 is equal to 25x squared. So we have a quadratic equation to solve. We could solve by factoring our quadratic formula, but because there are no linear terms, there's no plain x term, we can go ahead and we can solve this by square rooting. That'll be the most efficient method. So I'm going to divide over the 25 to isolate the x squared. So that's going to give me 4 equals x squared. And then I'm going to go ahead and square root both sides. And remember, when you square root a number, you need a plus or minus out in front of it. And that's going to give me that x is equal to positive and negative 2. Okay. But because this is a log equation, we need to go back and check for extraneous solutions. And if I go back to the original equation, the only location of a variable was right here, that x on the inside. And the domain restrictions for a log say that you cannot have 0 inside of a logarithm or a negative number. So when I plug in positive 2 for x, well, that's fine. But plugging in negative 2 will give me a negative inside of the logarithm, and that's our big bad no-no when it comes to logs. So we're going to cross this off. Our final answer is not, in fact, plus or minus 2. The final answer is just x equals positive 2 because of that extraneous solution. Okay? But again, it's important to show all possible solutions and then eliminate or discard the problems or the values that don't work in the original equation. Okay, so that's our first one. Let's take a look at problem number 4. So for problem number 4, same sort of situation, only now we have natural log, but I can still start by condensing, okay? So right here I have the subtraction involved. There were no coefficients to pull in, so the subtraction means I have the natural log of a quotient, so a division problem on the inside, and that's going to be equal to 3. What comes before the subtraction, that goes in the numerator. What comes after the subtraction goes in the denominator. All right, so now I'm going to need to convert this to exponential form again. And keep in mind, the base of a natural log is an e. So this is log base e of x over 4 is equal to 3. All right, so we're going to get a kind of funky answer on this one. So converting this to exponential form, we have this base right here, e, to the third power is equal to the inside expression, x over 4, all right? And our goal here is to solve for x. X is a variable, e is a number. So e to the third, that's something that we can do on a calculator. We're not going to do it just yet, though. To get an exact value answer, all I really need to do here is I need to multiply both sides by 4. So I get 4e to the third power is equal to x. And if a problem asks for an exact value answer, no rounding allowed, this would be your final answer. You could also type this into a calculator. Again, you would need to find the E button on your calculator. This comes out to approximately, excuse me, I wrote an equals, but it's an approximately 80.342. Again, that's an approximation. So the 4e cubed, that's the better answer because it's more precise, it's exact. But if you needed to, say, give a solution to an application problem down the road, it's going to be common for us to go to this decimal format. Okay, so that is solving equations with common and natural logs.